Right. So in terms of algebra or our paper one, right? Solving for x years, we know that will be our first question, and we have to ensure that we get total there. Like we must get all the marks. So here's an inequality, and I have a specific way of dealing with inequalities that I would like us to look at. So we have 15x minus 4 less than 9x squared. Now, so the first thing we'll do is to take the the terms to the left. So we'll have negative 9x squared. Then we still have 15x here. Minus 4 is less than 0. Now, working with this, having a negative sign there, it's a bit challenging, right? So what I would suggest is for you to divide everything by negative 1. By the way, some mistakes that I've seen students do is that once they take the 9x squared to the left, they even change the direction of the sign. No, good people would not do that. We only change the direction in this instance whereby we're dividing by negative 1, and we only change it after we have divided. So negative 9 divided by negative 1, we'll have 9x squared, and then we have minus 15x, and then we have plus 4, and then that's when we can change this sign to look to the other side, and then we'll have that. Okay, then from there I usually advise that if we do not know how to factorize properly, or we still struggle with factorization, just make yourself a nice flower there on the side with a pencil. It's regarded as rough work. Then I need you to write 9x squared minus 15x plus 4, but change the what? The sign to an equal sign. Then after that, use the quadratic formula to solve for the solutions, right? So you can say now x will be equal to minus, remember minus is outside, it's minus b, so you will say minus of negative 15, and then you say plus or minus the root of let me write the formula here, minus b plus or minus the root of b squared minus 4ac, all divided by 2a. So you shall say for b squared, that will be negative 15 all squared minus 4a, and then your c will be 4, right? I don't know if you can assist me there with some solutions, right? Otherwise, I can quickly just, yes?
X equals to 4 over 3, or x equals to 1 over 3.
Great stuff. Great stuff. Now, this is what we have. Then after you have written these, good people, I need you to know that these ones are your critical values. So you're going to take what you will do for me is that you will take the terms, all of them, to the left, meaning you're going to write this as x minus 4 over 3 is equal to 0. Then you say, or x minus 1 over 3 is equal to 0. Then I need you to just put brackets there. Good people, those two are your brackets, okay? These are what you call your what? Those are your factors. So immediately from this step, you're going to open two brackets, and then on those two brackets, you're going to put the first one, x minus 4 over 3, the second one, x minus 1 over 3. However, let's be honest, good people. If you were to factorize this thing, it would be very, very difficult or extremely challenging for you to be, saying the factors of 4 is 4 over 3 times 1 over 3. Let's be honest, good people. So for you to avoid showing the examiner the impossible, right, what you can simply do is that once you have the fraction, I need you to take the denominator and multiply it with the variable, meaning that I need you to write this as 3x, then just drop down the minus 4. Then on the second bracket, I need you to multiply the denominator by the variable, meaning write it as 3x minus 1. Now this one is realistic, an examiner can say, yeah, no, you did say the factors of 4 is 4 and 1, you see. Other than this one here, no. Even if you are a guru, it might be very difficult. So that is the steps there. Now you get a mark for the factors, now you get a mark for the standard form. Then from there you go to your critical values. The critical values is the second last step, right? You must write the smaller one and then the larger one. uh, yes, I see two hands. Can we start with yeah, Mr. Tatenda? Mr. Sean?
Oh, yeah, I was saying, so I still don't understand that part with the 3x. Like, how did you convert it?
How did I convert it?
Yeah, from the fractions.
No, I just multiplied by the denominator. It's just as the same as saying multiply by the denominator. Multiply by the denominator. You understand me? So
Oh, okay, I see.
yes. So same thing here. Same thing here. Multiply by the denominator. Multiply by the denominator. Then that will be fine.
Alright, sir.
Great stuff. So now critical values, you write the smaller one and then you write the bigger one here, right? This is 1,3333. This is 0,333. The 1/3. Then now you go to your what? You go to your number line there. On your number line you shall have 1/3 and then you shall have 4/3, right? Then from there you can say, remember it will be plus minus plus because you made sure that here it's positive. And then now the answer says greater than 0. You don't look at the one we originally had. You look at the one just before the critical values. It says greater than 0, which means positive, right? You take them that side. And then positive means you're going to the positive. Now I want you to drop down. Remember, I always say drop down the inequality as it is, right? Drop it down as it is and then put x, then put or, and then drop this one as it is and then put x. Then you have your full 4 marks there, right? So let's make sure that we always collect, especially on these type of problems, right? They are very nice. Next we have the nice one, the sets, right? Yes, Mr. Lema, you have a question?
Meneer, what if I just put it in the Casio calculator? The gray one.
The gray, which one?
The gray one, the FZ 991.
FZ. So sorry, sir, Ash, I'm not seeming to get you properly.
The one that we factorize, Meneer.
9x squared minus 15x plus 44 plus 4.
Yes, Meneer, and then I put it on the calculator that has a mirror.
That has a mirror. Like,
Yes.
so what would you get? Does it give you the factors 1/3 and 4/3?
Yes, Meneer.
Okay, that is probably a programmable calculator there, which is mostly not allowed. A calculator that gives you the factors completely, most of the times you don't allow that one. We want the one that you struggle to find those things there, okay? So but however, that one maybe would be, I don't know when it's beneficial, because in most cases you actually have a mark for substitution there. However, for this one here, I can say, yeah, you can use it to get the factors, but just be careful. I personally wouldn't like to recommend that one. I'm not sure if it's a programmable or it's the one that is allowed. Just make sure to inquire with your respective teacher there, just to avoid getting into trouble. Right, so what we can then say here, right, we can then say
Meneer,
yeah,
she is the one who gave us these calculators, Meneer.
or she says they are faster. No, that's
Yes, Meneer. It's the programmable ones.
I'm not really sure about it because I remember when I was in school there was someone who with that type of calculator who was not allowed to use it in the exams. So and maybe I'm not sure how things are working that side. But so maybe if she is the one, then you might be on the safe side. But right. So here you have 2x minus 2. We know the first mark we'll get is to isolate. Here we are chasing marks, good people. So we need to know what to do so that we collect the marks. So definitely we need to first of all start by doing what? Start by isolating. Then from there we can now so after isolating you can then square both sides, good people, to remove the radical signs, isn't it? You can then square both sides. 7 minus 2x, you have plus 1. You square both sides, you'll have 2x minus 2 is equal to, now this part here, right? Okay, you can say this 7 minus 2x plus 1 times 7 square root of 7 minus 2x plus 1. Then from there it's a tedious work whereby you have to say this times that will give you only what is inside. Then you say this times the 1, that will give you the very same thing, right? And then this times 1, meaning 1 times that, still the very same thing, right? I like this question a lot. It's very, very nice. So here from there you can then say, okay, I'll take everything to the left. You have 2x minus 2, then you can say minus 7 plus 2x minus 1. Then here this plus that, good people, will be 2 of that, right? Will be 2 of that. So now I took the negative 2x to the other side, that's why it's positive here. I took the 7 to the other side, that's why it's negative. I took the 1 to the other side, that's why it's negative. Then we can say 2x plus 2x, we get what? We get 4x. Minus 7, minus 2 minus 7 is minus 9, minus 1 is minus 10. And then you get 2 the root of 7 minus 2x. Now when you are here, you have two options, right? I'd like just to demonstrate the two options. So let me write option number 1. Option number 1, you can divide everything by 2, okay? Divide everything by 2, which means that you are going to write the very same thing. 4x minus 10 is equal to 2 root of 7 minus 2x. However, you divide everything by 2. I like dividing a lot, I like multiplying a lot. So you're going to have 2x minus 5 is equal to the root of 7 minus 2x, which makes it a bit nicer. Option number 2, you can decide to say it's fine. You will leave it as 4x minus 10 2 root of 7 minus 2x, but your next step will then be to what? To square both sides, to remove the radical sign, the root sign. So meaning that now you will have 4x minus 10 multiplied by 4x minus 10. And then here, be careful, because there is a 2 here, you are also going to square it. You're going to say 2 squared. The answer is what? Is 4. Then you're going to say the whole thing squared is going to be whatever is inside. Remember, the 2 is going to cancel the root. Okay. Then here, for this person who decided to divide, now they are only squaring on this option, on this step there. So that now they have 2x minus 5, 2x minus 5, and then they have 7 minus 2x. Then from that simplification, good people, 2x times 2x, you have 4x squared. 2x times that is negative 10x. Then you have negative 10x. Then you have 25. And then you have 7 minus 2x. Right, then from there you have 4x squared minus 20x plus 25 is equal to 7 minus 2x. Now simplifying that further, 4x squared minus 20x plus 2x plus 25 minus 7 is equal to 0. Now you are busy only simplifying, right? Busy only simplifying. Now here on the person who did this, they have a lot of work. 4x times 4x, they get 16x squared. 4x times that, they get negative 40x, and then they will get negative 40x, and then they will say plus 100 is equal to 4 times 7, that will be 28 minus 8x. So when they simplify, good people, they are still going to go to the same thing there. I would like to say from here, I know you are able to solve for x, ne? Yeah, I'd like to say from there you are able to solve for x. My main issue was to show you what to do when you are starting the problem and how to maneuver that. Are we okay there? All right. So now next one, right? Like I said, we're just dealing with some rapid fire questions to get us in the goal. So here they say to us we must solve these following equations simultaneously. Yeah, good people, remember simultaneous equations. Usually I know we prefer substitution, so you need to work on a equation with lesser information that is not too much complicated. For example, you can from here and say I want to make A the subject of the formula or I want to make B the subject of the formula. Guys, we can't do that. It's going to be extremely difficult. So try to work with the side that will allow you to do your thing there. So we're going to work from this one. We can just call this equation. Okay, we're going to say since we have log 2a plus 5, we're going to change this to exponential form. Let's understand the concept of changing something from exponential to log. Remember, from exponential to log form, you say the exponent is equal to log of the base, and then you say into the answer. That is how you change the exponential to log. Now, for example, right, example, let's say you have you already have it in exponential. You have 5 is equals to 2 to the power of x. Now what you will do is that you are going to say what is the exponent. The exponent is x, so you will write x, then equal sign, then you're going to write log. What is the base? The base is 2, so you write 2, and then what is the one that is on the other side will then be the answer, and then you put it in there. Then you have solved for x. You can put that in your calculator, you will get the value of x, right? Another example, just to get us moving there. Let's say you have 8 is equal to 1 over 3 to the power of x minus 1. How would you turn this into log form? It's in the exponential form because you see there's a base and an exponent. It's an exponential form. To get it to the other side, you check what is the exponent. The exponent is x minus 1, so you write x minus 1, then you say log, and then what is the base, right? The base is 1 over 3, so you write 1 over 3, and then what is the answer? Here it is 8. Again, you have that. So therefore you have x is equal to log of 1 over 3, 8, and then plus 1. Then if you put that in your calculator, you have solved for x. Okay, you have solved for x. That is from exponential to log. Then how do we change, or rather how do we move from a log to exponential? How do we move from log to exponential? So to move from the logarithmic form to the exponential form, it's the reverse process. For example, so you're going to say the very same thing. You're going to say answer is equal to base, and then you say exponent. You're going to turn it into this form. That is turning from log to exponential. For example, let me give you an example. let's say you are given that 5 is equal to log, no, sorry, let's say you are given that x is equal to log 2 and then 5. How would you turn this to exponential now? You are given in log form, you need to turn to exponential. You use this. You are going to say, what is the base? I always start with the base. The base is 2. It's always found here. So your base is 2. What is the exponent? The exponent, remember, is the one that is starting there, right? It's the one that is starting. And then the answer is the one in the brackets there. So as you can see, it's a reverse process. So you just check for the base and the exponent. This there will be your base. This here is the answer. This here is the exponent. Right. Let me give you another example, just one last example. Let's say you are given that y is equal to log 1 over 3 into 8, right? How would you turn that to exponential? You simply write what is the base. The base is 1 over 3. The exponent is what? Remember, the exponent is here, and then you say it's equal to the one in the brackets. That's how you turn from log to what? To exponential. Right, so here we're given in log form. We need to turn it to exponential first by saying what is the base. The base is 2, so you're gonna write this as 2, and then the exponent, remember, is the one there, and then the answer will then be that in the brackets. Then you say, therefore, 2 to the power 3 is what? It's 8, is equal to a plus 5. Look at how simple it is now. You can now simply say 8 minus 5 will be your a. Therefore, your a will be 3. So now you have your a. You now substitute the a where? There to solve. So now you simply say, therefore, from this you will have now 3. When you see a, you are putting 3. Then you have b squared minus 2 into a, which is 3. And then b minus 8 is equal to 0. Which means you have 3 squared, which is 9, b squared, minus 6b, and then minus 8 is equal to 0. Now you can do what? Now you can just use the quadratic formula to solve there. Or you can use the calculator, Mr. Liema's calculator, to get the answers very, very quickly. Mr. Liema, please assist us. Please assist us with the answer. I think mine can do that also, because mine, I know it's already programmable, this one. Then you have minus 6, and then you have x, and then you have minus 8. Okay, shift, calculate, yeah. So good people, your b, right, your b will be what? Will be negative 2 over 3, or your b will be equal to what? Will be equal to 4 over 3. Then you are done. You solve for a and b. You solve for a and b. Okay, so that is it, guys. Now we head to calculus. We cannot leave calculus behind. In everything we do, try not to leave calculus behind. The easy things. You must always have them so that they assist us. All right, so now in terms of this one here, we are given that they say determine the derivative, right? Let's just remember how to determine the derivative using our rules. So for 8.2, we shall say what? Before we can find the derivative, we need to simplify first. So we still write it as f of x first. Then we say we're gonna write that as 2 root x minus 1 over x to the power of 2. We need to simplify it first. So let's write it as 2 and then x to the power of half. Let's remember that the root sign is to the power of half. And then let's remember that if something is a denominator, when it goes on top, it has a negative exponent. Okay. Then from there, let's if you were in varsity, I would say let's use the chain rule, but no, here you are still in grade 12, so we're simply going to expand and write this as the following, right? And then write this as the following. Aish. It's nothing more that I enjoy than maths, guys. Aish. All right, so especially engineering maths, yo guys, things are happening there. So here we say this times that, 2 times 2, that will be 4, and then x to the power half times x to the power half, what's happening? That will be x to the power of half plus half. Remember, bases are the same, we add the exponents. Then we say this times that, it will give us what? 2 times -1 is -2, and then this times that will give us x to the power of half plus -1, because now we are adding the exponents. Same thing here, this times this, we say -1 times 2, that will be -2, and then you have x, then you're going to have -1 plus half there. Then you say -1 times -1, that will be 1, and then this times that will be x to the power of -1 plus 1. We need to simplify first, good people, before we can apply the rules. Half plus half is 1, so I can just write it as 4x. Half minus 1 is -half. Okay, it's -half. And then you have what? -2, and then half -1 plus half, that is still -half, and then you have yourself 1x to the power of what? 0. So to simplify that further, you have 4x, and then you have minus 4x to the power of -half, because these are like terms. And then here, good people, is just 1 times 1, because x to the power 0 is 1, so you simply have plus 1. So this is your nice f of x. Now we can apply the rules, ne? So therefore we then say, therefore the derivative now will be equal to, remember here we just take 4, because the exponent is 1, we just take the coefficient, and then here we say this times that. -4 times -half, good people, it's 2. And then you have x, then you say -half minus 1. You remember to subtract 1 from the exponent. The derivative of this is what? Is 0, because it's a constant. So your final answer will be 4 plus 2x to the power of -3 over 2. If you even want to take it further, you can say 4 plus 2 all over x to the power 3 over 2. If you still want to go further, you can say 4 over the square root of x cubed. Then that will be your answer. But ending here would give you full marks. All right, then we can go to the to 8.3. Remember, if you do not understand any part, please don't hesitate to ask them. Then we have 4, right? We have some interesting things going on there. Let me do this so that I can write it. It's what there? It's f of x is equal to 3x cubed minus 3x squared plus 6x minus 2. Yes, Mr. Tatin. Mr. Shaw.
So that is how we end the derivative question.
Yeah, you are done.
Okay. I see.
All right. So here they said determine the interval for which f is concave up. The interval. Ooh, okay. Concave up and concave down, good people, means that you have to find the second derivative. The moment they say concave up, concave down, we need to find the second derivative of this. Okay, so let's understand that a graph will be concave. A graph will be concave up when the second derivative is greater than 0. And then a graph will be concave down graph would be concave down when the second derivative is less than 0. Okay, concave. Yeah, so that's what we need to do. We need to find the second derivative. So from here we're going to start finding the first derivative. Right, the first derivative would be what? It would be 3 times 3, that will be 9. And then remember, you say 3 minus 1, you get what? 2. Negative 3 times 2, you get negative 6. And then you say 2 minus 1 is 1. Then remember here exponent is 1, so you just take the coefficient. And then derivative of a constant is 0. Then you go ahead and find the second derivative. 9 times 2, that would be 18. And then 2 minus 1, that would be 1. Ne? Then here the exponent is 1, so we just take the coefficient. The derivative of a constant is 0. Now that we have the second derivative, good people, we are going to equate that second derivative. So we go here. We are going to equate that second derivative to 0 so that you get the x coordinate whereby the concavity changes. You find the x coordinate of the point of inflection. So we are going to say 18x minus 6 is equal to 0. You say 18x is equal to 6. You divide by 18. You divide by 18. Therefore, your x will be equal to 1 over 3. Good people, when it is concave up, therefore, for concave up, it's when x is greater than 1 over 3. Then you are done. Concave up means you say this is greater than 0. Yeah, and then so simply you all the time, good people, just find the x, and then that x is greater than 0 when it's concave up, and then less than 0 that's when it is concave down. X less than 1 over 3 is concave down. Yes, Mr. Lema.
If I made an equality sign, would I get the full marks?
This is the inequality sign here, or which sign is you are referring to, sir?
I'm talking about when they ask concavity, it's the second derivative. So if I turn that second derivative into a inequality, would I be okay?
So meaning that to say it's when it is greater than 0, like this, and then you write 18x minus 6 is greater than 0.
Yes.
It will still be okay. It will give you the same thing. You will have 18x is greater than 6, and when you divide by 18 both sides, you are going to get this one. Okay?
Yes.
Yes, same thing. In fact, it's even nicer that way. Yeah, even it's nicer that way. Right, good people, that was your concavity. Then the last question, right? We work today. The last question I have for you guys is this one. I definitely think tomorrow you guys will be doing the working most of the time. I just wanted to give us a nice recap of the principles we need to apply. Now here we have another question, right? It's asking us to say that given that they determine T6. I chose that question because I know we usually neglect it. That when we are just given a sum, you see, we forget to find the term when we are given the sum. So hence I chose that one. So for 3.1, good people, let's remember this formula. Tn is equal to Sn minus S of n minus 1. Okay, so if we want T6, right, as the question requires us to do, we are simply going to say T6 is equal to sum of 6 minus sum of 6 minus 1, which means sum of 6 minus sum of 5. So we're simply going to substitute 6 here for n to get the sum of 6. So we're simply going to say 4 into 6 squared plus 1. Then we say minus 4 into 5 squared plus 1. Then you simply put that in your calculator to get T6. So I see what is happening here. This is this is a lot. That's a lot. So we're simply going to put that in the calculator. We have 6 squared, you have plus 1, and then minus 4 into 5, and then you have a squared, and then you say plus 1. Then you are going to get 44. So T6 is 44. Great stuff. That is it, guys. 3.2. For which values of x will the following converge? I chose this again because I know we usually forget about those things. Good people, when a series converge, it's when r is between 1 and -1. I like to say that this means that when r is a proper fraction, a negative or a positive proper fraction, meaning that if you have a over b, a must be smaller than b, then you have a proper fraction. If r is like that, then definitely you're going to have sum to infinity. Definitely the series is going to converge. Because sometimes they ask you for which values of x will the sum to infinity exist. Now, good people, here it definitely means you just have to find r first. Ne? So how do you find r there? Remember that the series will the series will converge. The series will converge when r is between 1 and -1, which means we must find r. Remember, r we're going to say t2 minus t2 over t1. So I can just simply say this over that. So I will say 4x minus 3 squared over 4x minus 3. And then I just say less than 1. Good people, the bases are the same. You simply subtract the exponents because you are dividing. 2 minus 1 is what is 1. So you are simply going to have 4x minus 3 to the power of 1. Which means you simply have what? You simply have 4x minus 3. Then you are going to solve for the inequality as if you are a grade 10 learner, whereby this number you're going to take it to that side and that side, and it's going to change the sign. So you're going to have what? You're going to have -1 plus 3, and then you're going to say 1 plus 3. So you just take that number to both sides, you change the sign. -1 plus 3 is what? Is 2, and then you have 4x. 1 plus 3 is 4. Good people, you are not done. Then there is a 4 here, right? So you divide by 4 and you do that throughout. So therefore you're going to have half, and then you're going to have x, and then you're going to have 1. So those are the values of x for which the series will converge. As simple as that. As simple as that. Okay. Right. Last question. It's a sigma notation. We are given 5, and then what do we have there? Right, 5, and then you have k is equals to 3, and then what do you have? Let me do this. Remember, yeah. Right, and then you have -1, and then you have k, you have multiplied by 2 over k. 2 marks, good people. They want you to find that. This is not difficult, good people. It's very, very nice. So what you simply do is that k is 3 until 5. How, good people? I don't think that will take us a lot of time. You simply substitute that -1, and then you put 3, and then you say multiply by 2 over 3. That is your first term. And then you simply say plus -1, and then remember the exponent is k. Where you see k, now you're going to put 4, and then times 2 over 4, and then you say plus, lastly, -1 into 5 times 2 over 5. I know some people would think there's a crazy formula we have to get. No, good people, just go to your calculator and get the answer there, right? So you simply put that in your calculator by saying what? negative 1 cubed, right? And then you say times 2 over 3, right? And then you say plus that will be 2 over 4, right? And then you say plus minus 2 over 5. So the final answer will simply be minus 17 over 30, and then we are done for today. Right, so I hope that gave you a refresher into calculus, a refresher into sigma series and sequences, a refresher into your what, some algebra there. Then next time we shall talk about functions, we shall talk about probability, we shall talk about finance, to continue our quest for revision. Okay, are we okay, guys? Any questions? Yes, Mr. Liama?
Meneer, is it possible if we could have our 2 hours class back?